what if we had x is greater than a number? For example, if x is greater than 5. Well, it's the same deal. If x is greater than 5, can x be 5? No, x cannot be 5. So again, we're going to put a circle on the 5. And if it's greater than 5, what direction do I go on in the number line? This time I'm going to go to the right because all the numbers greater than 5 are to the right of 5. So if I graph this, here's 0, 1, 2, 3, 4, 5, 6, 7. If I graph this, again, it says x is greater than 5. I know x cannot be 5, so I'm going to put an unfilled or open circle over the 5. And since x has to be everything greater than 5, I'm going to go to the right because that's where all the numbers greater than 5 are. 6, 7, 8, 20, 50, 1,000, a million. Okay, and this arrow right here tells me that this line is going to go on forever. So everything to the right of 5 is a possible solution, which it is. So that's 2 of my 4 inequalities. Now let's see what happens if I've got, let's do red, x is less than or equal to a number. For example, if x is less than or equal to, let's say 1. Okay? If x is less than or equal to 1, well, this time, can x be 1? Remember, it's less than or equal to, right? So can x be 1? Yes. So to show that x can be 1, now instead of leaving it in an unfilled circle, I'm going to fill that circle in to show that I'm including it. Okay, this is the inclusive circle. The filled in circle is the inclusive circle. And if I want to be less than 1, I have to go in which direction? Good, to the left. So if I do this, let's go -2, -1, 0, 1, 2. I want to show that x is less than or equal to 1. So I'm going to put a circle around 1 and I'm going to fill it in. Okay. And then because x can also be less than 1, I'm going to go to the left. And I'm done. This shows me that x can still be 1 because it's a filled in circle. And it's going to go to the left. And there will be an arrow at the end to show that all of the solutions that are less than 1 are possible. I've seen a lot of students stop and not put this arrow at the end. That's wrong. If I just stopped here, or even here at the end with no arrow, that just tells me that my solutions end, okay? And they don't. So for example, and this is a wrong example, don't do this. Here's 0, here's 1, here's -1. This is what I don't want you to do. That doesn't tell me anything. That just tells me that your solution stops. This arrow tells me that it goes on forever, which means there's an infinite amount of solutions, which there are. X can be so many different numbers. Literally anything less than or equal to 1. And finally, now we've got x is greater than or equal to a number. So let's say x is greater than or equal to -2. Well, we already talked about if it's less than or equal to, we did what with the circle? Good, we filled it in. We made it an inclusive circle. Well, because of this or equal to symbol, we're going to make it an inclusive circle. And if x is greater than a number, to show numbers greater than, which direction are we going to go in? Good, the right. Okay. So now, when I make my number line, -3, -2, -1, 0, 1, 2. Now, when you make a number line, I've had students ask me this in the past, make sure that your increments make sense. Like, don't put -2 and then like 0, 3. Make sure that you're at least, like, you can go by twos. This could be -4, -2, 0, 2, 4, 6. But don't just give me random numbers with no sort of like pattern to them. Okay, make sure your increments are at least somewhat, that they make sense. Okay. All right. Now last one, let's go with green. So we said x is greater than or equal to 2. So if it's, or -2. If it's or equal to -2, we're going to use the inclusive circle. That's why it's filled in. And everything greater than -2 is on the left. And we put an arrow to show that it goes on forever. Okay. So to summarize what we just did, if x is less than a number, we're going to do an open circle and go to the left to show that all of the possible values of x to make this inequality true are all to the left of whatever that number is. And we keep it open to show that it doesn't include that number. X is greater than a number, same deal. Open circle, the non-inclusive circle. And this time we go to the right to show that everything but that number and everything to the right of it is a solution. X is less than or equal to a number. This time we're going to use the filled circle, which is the accepting circle. So we're going to accept that number because it's or equal to, and we're going to go to the left. Okay, it's my inclusive circle going to the left to show that everything including that number and everything less than that number is a solution. And x is greater than or equal to a number. Same thing, inclusive circle, but this time because x is greater than or equal to, we're going to the right. Okay. And that's it for simple graphing of inequalities. In the next video, we're going to get into solving inequalities. So hopefully this made sense. Let me know if it didn't, okay? I can answer any questions you have.